Hi everyone, today I have a really cool problem for you and it's going to involve functional equations, and there are a couple of ways to solve this, and I'm going to use the one that is a little bit simple. Okay, and this is the problem number 3 from the International Math Olympiad in 2015, and in this video we're going to be learning about functional equations, or more importantly the substitution strategy. It's probably one of the most common and the most important substitution strategy, one of the most common strategies for solving functional equations. Then we have book sessions of functional equations, and at the end we have a similar but challenging problem.
This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
So let's get started. So the question asks us to find all functions f mapping from real to reals so that it satisfies the given functional equation, right? So they've given us f of x squared plus y times f of x is equal to x times f of x plus y. Okay, now what can we do over here? So let's just start with some basic substitutions. Probably the most common one is plugging x equals 0 and y equals 0 to see if we can get some result which we may use in the future. That leaves us with f of 0 over here is equal to 0. Right, so on the right hand side it will essentially be 0 times f of 0, which is 0. So f of 0 is equal to 0, which might be needed in the future. Let's just save it. Right, now the second substitution that I'm going to make is I'm going to plug x equals to x, and I'm going to plug y is equal to 0. And when I do that, I will essentially get f of x squared is equal to x times f of x. Now at this point I'm going to make a claim. And this is actually a fairly common result. A lot of people know this, that when f of x squared is equal to f of x times f of x, this implies that f is odd. As well, we can neatly prove that as well. So just substitute x with minus x, which is a very common technique to see if a function is odd or even. So on the left hand side we'll get f of x squared will be minus x times f of minus x. And if you see on both those equations 2 and 3, the left hand side is the same, so you can equate the right hand side and you will get this. And if I just cancel x on both sides, I'll get f of x is equal to minus of f of minus x, which satisfies the definition of odd function, so therefore f is odd. Essentially prove that f is odd, right? So now that f is odd, right, now what we can do? So now I'm just going to plug in x equals to x and y is equal to minus x, right? And when I do that, I'll get something like this: f of x squared minus x times f of x is equal to x times f of 0, and f of 0 is essentially 0, so I'll get f of x squared minus x times f of x is equal to 0. Now now I can really split it up into two cases. So I'll just split it up into two cases. So case 1 will be that there exists an a such that x squared minus x times f of x is equal to 0 and f of a is equal to 0, right? And a is obviously not equal to 0, right? So there exists a non-zero a so that this satisfies f of a is equal to 0 and a is equal to x squared minus x times f of x, right? Now at this point what I'm going to do is I'm again going to use a little bit of substitution. I'm going to plug in x equals to a, and I'm going to plug in y is equal to y, and let's see what we get over here. Now once I do this, I will get f of a squared plus y times f of a, okay, and that will be equal to, on the right hand side I'll get a times f of a plus y. So essentially f of a is equal to 0, and if I just substitute a for a square, I got f of a square is equal to 0. So essentially the left hand side is 0, right? So we can just say that a times f of a plus y is equal to 0, which basically means that f of a plus y is equal to 0. And well, you can just take a plus y is equal to t, and we'll get f of x equal to 0, which is indeed our first solution. You can plug it back into the functional equation to see if it works or not. Okay. And this is actually our first solution. And okay, over here assume that there exists such an a, right? There exists such an a such that this quantity is equal to a and f of a is equal to 0. And let's just case 2, such an a does not exist, such a non-zero a, need to be a little bit more specific, so such that a non-zero a doesn't exist. We will simply have x squared minus f of x squared is equal to 0. It essentially means that f of x squared is equal to x squared, or f of x is equal to x. So you have two solutions, f of x is 0 and x, and you can actually see that both of them are actually working by plugging them back into the original equation. Okay, perfect. So yeah, that was it. That was one way to solve it. The other one would be to use a concept called as surjectivity. So it can be solved using that as well. What does surjectivity mean? So surjectivity means that there has to exist an x for every y so that f of x equal to y, right? So for every y, there needs to exist a certain x so that f of x equal to y. That's kind of the definition of surjectivity, and you can try using surjectivity as well. How would you prove that this function is surjective or not surjective? I'll give you a hint. To check for surjectivity, I'll not tell you if it is surjective or not. To check for surjectivity, I'll just give you a little bit of a hint. You can substitute x as x over f of u, and you can substitute y as u minus x over f of u. And you can actually let me know if this is surjective or not. Maybe you've already figured it out, maybe you tried by yourself, but you can check for surjectivity as well, and that would be another method to solve this. Yes, we have book suggestions for functional equations. Functional equations by B.J. Venkatachala, and functional equations how to solve them by Christopher T. Small. It's a little bit of an advanced book, but it's also really nice if you like functional equations. And both of these are obviously really good books for the Olympiads. And now after that we have a similar but challenging problem. So again, we need to find all functions mapping from real to reals so that it satisfies the given functional equations for all reals x and y. Maybe try using the idea of surjectivity here as well, and yeah, see if you can solve it. Some basic substitution should be enough for this problem actually. As usual, if you make any progress on it or if you're able to solve it, please let me know in the comment section below. And until then, I'll see you in the next video. Bye-bye.
The programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit chinta.com.